Shell and tube heat exchangers introduction. Chapter 1. What is a shell and tube heat exchanger? A shell and tube heat exchanger (STHE) is a type of heat exchanging device constructed using a large cylindrical enclosure, or shell, that has bundles of perfectly spaced tubing compacted in its interior. Heat exchanging is the transfer of heat from one substance or medium to a similar substance or medium. Shell and tube heat exchangers are the most common form of heat exchange design. They are classified according to their properties, tubing type, and other characteristics. The use and popularity of shell and tube heat exchangers is due to the simplicity of their design and exceptionally efficient heat exchange rate. The process of a shell and tube heat exchanger involves the use of a liquid or steam that flows into the shell to heat the tubes. 4 passes through the tubes is considered to be the most efficient and effective method of heat transfer. Chapter 2. Shell and tube heat exchanger design. Shell and tube heat exchangers are engineered using sophisticated and technical computer design parameters. The components of the device include the shell, shell cover, tubes, channel, channel cover, tube sheet, baffles, and nozzles. The specifications and standards for STHEs have been established by the Tubular Exchanger Manufacturers Association (TEMA). Prior to producing a shell and tube heat exchanger, there are several pieces of data manufacturers require, such as flow rates, inlet and outlet temperatures, pressure, pressure drop, resistance factors, physical properties of substances to be processed, line sizes, and the shell diameter. Added to these basic factors are more technical requirements that are used to determine the best process to produce the correct heat exchanger for the application. Shell and tube heat exchanger design. Shell. The shell of a shell and tube heat exchanger is made of pipe or welded metal plates using materials that can withstand extreme temperatures and that are corrosion resistant. The inner shell must be round with a consistent diameter to minimize space between the baffled outer edge and the shell. Channels or heads. The type of channel or head depends on the use of the shell and tube heat exchanger, with bonnet-type heads being the most common for use in applications where the head does not have to be removed frequently. Removable cover channels, necessary for maintenance, are flanged or welded. When frequent examination of the channel and tubes is necessary, a removable channel cover is necessary. Tubes of a shell and tube heat exchanger are welded or extruded and made from carbon steel, stainless steel, titanium, Inconel, or copper. Tube diameters of 0.625 inch 16 mm, 0.75 inch 19 mm, or 1 inch 25 mm are used in compact heat exchangers. The thickness of the tubes is chosen for pressure, temperature, thermal stress, and resistance to corrosion at lengths of 6 to 24 feet or 2 meters to 7 meters. Tubes that are longer reduce shell diameter and result in high shell pressure drop. The tube sheet is a plate or sheet that is perforated with holes for the insertion of pipes or tubes and designed to support the tubes on either end of the cylindrical shell. The shell extends beyond the tube sheets and is sealed on both ends to form the enclosed chamber that is covered by the heads. Tube pitch. Tube pitch is the distance from the center of a tube to the center of an adjacent tube. Tubes are laid out in a triangular or square pattern, with the square pattern configuration being the easiest to clean and producing the least amount of turbulence. The square pitch arrangement allows vapors to rise between the tubes, an advantage over triangular and rotated square pitch tubing. Baffles are used to direct the flow in the shell and tube sides such that the fluid velocity increases sufficiently to reach a high heat transfer coefficient and significantly reduce fouling, which is when unwanted materials form on the heat transfer surface. The accumulation of fouling increases heat transfer resistance and leads to poor heat exchanger performance. In horizontal shell and tube heat exchangers, the baffles support the tubes and prevent sagging or vibration damage. Tie rods and spaces. Tie rods and spaces are supports and structural components designed to hold the baffles in place as well as maintain the space between the baffles. The number of rods and spaces is determined by the number of baffles and the diameter of the shell. Tie rods are screwed to the tube sheet and extend a bundle's length to the last baffle.